All right, really starting to get fun now. So we're going to use matrices to do transformations of graphs or points. Now, if you remember from previously, you should remember that if we're doing a reflection in the x-axis, the x stays the same. This is the y goes to minus y, yeah? Reflection in the y-axis, y stays the same, x goes to minus x. Dilation factor of k, so that just means, it could be a dilation factor of 2, 3, 4, 5. If it's from the y-axis, the y stays the same, the k, the x just gets multiplied by whatever the dilation factor is. Similarly, if it's in the x-axis, the x stays the same, the y changes. And you might remember when we were doing inverse functions that the x and the y swap, don't they? So x becomes y becomes x. Now we can take those take this notation and just change it slightly. So watch what happens here. We've still got a reflection in the x-axis, the x doesn't change, and the y goes to minus. So if you think, if we put in 0y, 0x, that makes no difference at all, does it? So that is just x equals, and 1x we know is just x. So that is just the same as x equals x, yeah? So it's just x equals x, it's just written in a different way. Some of you might go, oh, I can see, it just looks like a matrix. So that one, 1, 0, 0, minus 1. So it just looks like a matrix, and we can do that for all of those. And note this one here looks a little bit like the identity matrix. So take care with that. Remember, the identity matrix is 1, 0, 0, 1. So we've got these matrices which we can use when we're doing reflections, dilations, etc. Okay. So this is just a bit of reminder that when we're multiplying matrices, we times this by this by this, etc. Remember when we watched that video, if you played it a few times, where it explains that you do your running and your jumping, all that sort of stuff. So this is just revision of that. So let's look at this. This is quite a weird example. So we've got a linear transformation. So this point here goes to that point there. So something happens to move that point there to that point there. And the same thing, whatever this transformation is, changes this point to this point. So what we want to do is, taking the information from these two, find out what happens to that point. So let's just look at the way we've set it up. So we're saying some transformation changes this to this, which is this to this, yeah? And that same transformation, let's do A, B, C, D, changes this to this, changes this to this. So now we can just say, well, we know that's going to be A times 1 is A, B times 0 is nothing. So we know that A is going to be 3. Similarly, if we apply that transformation, that C is minus 1. And we can do the same together. It's kind of like simultaneous equations, but not really. We do A times 0 is 0, B times 1 is 1. So that's just B. So B is minus 2. So now we've got our matrix. So this is the matrix that changes that to that and changes that to that. So now we're just going to do, what is it going to do to that point? So that's what we're trying to find. We're trying to find what happens to the point minus 3, 5. So it's okay. This is what we want to try and find, and it's going to be this matrix times this. So if we just apply our matrices rules that we know, that times that, that times that, we get minus 19, 23. Don't forget, we're working in coordinates, so we want our answer to be minus 19, 23. Now, when I looked at that one, it just looks like such a weird answer. So I thought, okay, me being my visual learner, I'll see if I can have a look at this as a graph. So what it's saying is the point 1, 0 moves to 3 minus 1. Okay, so that one's going that way. It's going down and to the right. And it's also saying that that same transformation changes the point 0, 1 to 2, 4. So that was even going in the other direction. If we look at the actual solution that we did, minus 3, 5 goes to minus 19, 23. We've actually got that. So there's no way that I could have visually worked out that that was going to happen. I would never have thought that this transformation here would be the same transformation to change those graphs. So this is telling me, okay, algebra is really, really useful here. I need to be able to know how to do this because I'm never going to be able to work this out graphically. All right, let's look at another example. So this point here has a reflection in the x-axis followed by a dilation factor of k from the y-axis. Okay, so let A be the matrix from the first one, B from the second one. This is just from this table here. So reflection in the x-axis is that one. Reflection of dilation factor of k from the y-axis is that one. So basically that's A and B, and we've got to join these two together. So I'm joining these two together, and when I join these two together, I get this matrix. Now some people say, oh, it's easy to do because I've got a k there and a 1 there. 1 times k is k. That's a naught, that's a naught, so that stays the same. That's a naught, that's a naught, that stays the same. That's a -1, that's a 1, so it becomes a -1. So just take care if you're trying to do some shortcuts there. So there's my matrix that's going to do my transformation. So I'll say, okay, this is what I'm going to do to BA. So I'm going to do this times this. So I do k times 2, 2k, 0 times -3, 0, 0 times -2 is nothing, -1 times -3 plus 3. So the image of 2 minus 3 is 2k 3. So just take care that you don't leave your answer like this, because it's given in this form. We need to give our answer in that same form. All right, there's some notes for you. Make sure you memorize all these, because if it's non-calculator, you're going to need to know it, aren't you? Good luck with those questions.